electronic configuration of atoms and ions. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. We have learned in the previous video that when n is equal to 1, it is K shell and it has one subshell 1s. When n is equal to 2, it is L shell and it has two subshells 2s and 2p. When n is equal to 3, it is M shell. It has three subshells 3s, 3p and 3d. When n is equal to 4, it is N shell. It has four subshells 4s, 4p, 4d and 4f. Thus remember that 1s is the subshell of first or K shell, 2s, 2p are the subshells of second or L shell, 3s, 3p, 3d are the subshells of third or M shell, while 4s, 4p, 4d, 4f are the subshells of fourth or N shell. Also remember that S subshell can accommodate only 2 electrons. P subshell can accommodate only 6 electrons. D subshell can accommodate 10 electrons and F subshells can accommodate 14 electrons. The easy trick to remember the number of electrons in subshells is to write here 2 and then add 4 electrons to it successively, like 2, 6, 10, 14. Let me repeat it. 2, 6, 10 and 14. Now let me teach you the electronic configuration of carbon atom. We know that the atomic number of carbon atom is 6. Means that there are 6 electrons and 6 protons in the carbon atom. But we only need the number of electrons. I cut the 1s like this and write here 1s. We know that S subshell can accommodate only 2 electrons. Then I cut 2s like this and write it here. 2s can also accommodate 2 electrons. Then I cut 2p and 3s and I write here 2p and 3s. We know that P can accommodate 6 electrons, but wait a second. There are 6 electrons in the carbon atom. We have already configured 4 electrons in these S subshells. So we therefore write only 2 electrons in P subshell. 2 plus 2 plus 2 is equal to 6. We do not need this 3s subshell, so I erase it. This is the electronic configuration of carbon atom. Carbon atom is also known as a p block element because its valence electrons lie in the p subshell. Now let me teach you the electronic configuration of positive ions or cations like iron ion. Positive 2 means that iron atom is in profit because it has given 2 electrons and ln. Remember that always write the atomic number of neutral atom if you do electronic configuration of positive ions and forget about the positive ion for a while. So the atomic number of iron atom is 26. We know all about the subshell system. I cut 1s and write here 1s. Then write 2 over 1s. I cut 2s and write 2s here. I write 2 over 8. I cut 2p and 3s and write it here. I write 6 over 2p and 2 over 3s. Then I cut 3p and 4s. I write 6 over 3p and 2 over 4s. Then I cut 3d and 4p. I write here 3d. Now 2 plus 2 plus 6 plus 2 plus 6 plus 2 is equal to 20. We need the configuration of 6 more electrons. So D subshell can accommodate 6 electrons. So this is the electronic configuration of neutral iron atom. But we need the electronic configuration of iron ion. Positive 2 means we have to remove 2 electrons from this electronic configuration of neutral iron atom. But the question is, which 2 electrons should we remove? Well, we remove 2 electrons from the highest sub-energy level 4s, not from 3d, because 4s is the subshell of 4th or n shell, while 3d is the subshell of 3rd or m shell. So 4s is the highest sub-energy level. Hence, this is the electronic configuration of iron ion. Iron atom is also called as d block element because its valence electrons lies in the d subshell. Lastly, let me teach you electronic configuration of negative ions or anions like fluorine ion. Negative means that fluorine atom is in loss because it has taken loan from someone. We know that atomic number of neutral fluorine atom is 9. Now add this 1 electron taken as loan by 8. So we get 9 plus 1 is equal to 10 electrons. In case of negative ions, just configure the total number of electrons. We already know about the subshell system. So I cut and write here all the subshells I needed, like 1s, 2s and 2p. We know that 1s and 2s can accommodate 2 electrons and 2p can accommodate 6 electrons. 2 plus 2 plus 6 is equal to 10. So this is the electronic configuration of fluorine ion. Fluorine atom is also known as a p block element because its valence electrons lie in the p subshell. This was all about electronic configuration.